All right, so this lesson is about reference points and trig functions. So far you have learned how to do, you've learned the unit circle, that has a radius of 1. You've learned about degrees and radians and how to go between those. So now we're going to talk about when I say reference points, I actually mean coordinates, like these actual points on like a coordinate plane, an XY plane. And we're going to talk about that. So a few points that are easy to recognize, and I'll just draw like a quick picture for you. What I'm showing you right here is just the first quadrant. So that's what this is. The points that you should know pretty easily are the origin is here in the middle. That's 0, 0. You're not really using that. I'm just showing you that the circle is centered. And the unit circle has a radius of 1. So this is that radius, right? It's got a radius of 1. So if that radius goes over to the right 1 whole unit, that means that this coordinate right here is 1, 0. You see that right here on that little coordinate that I've given you. And then if you go up, now your coordinate is 0 because you're not going left or right any, but you're going up 1. All right, so you can use that same kind of philosophy to go all the way around. So make sure that you have kind of that in mind. And I'll show you the whole circle here in a minute, so you don't necessarily need to copy anything down unless you just want to jot these quick ones down. So let me show you, there is actually a pattern to help you figure out the coordinates for the rest of these. And so I'm going to erase this and then show you that pattern. All right, so the pattern that we're going to be using is square root. The way that you count is square root over 2. And I'm going to start with the y values. Sorry, not with the y values. Oh, yes, with the y values. I'm going to start with the y values because they count from 0, and I've got to miswrite this, 0 up to 1. So if we just look at the y values for a moment, 0. Notice what's happening as you move around the circle. So we start on this same end like we usually do, and I'm counting square root over 2. So this is the same as the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2, and the square root of 4 over 2. And you might say that some of those look different, but for instance on this one, the square root of 1 is just 1, so that's why we write 1/2. This is the square root of 2, square root of 3, square root of 4, that's a perfect number. The square root of 4 is 2, and 2 divided by 2 is just 1. This pattern goes the same way. It's the same pattern actually, but for the y values it just goes in the other direction. So notice x values start where they should start. I'm saying these words backwards, I'm so sorry. Y values start where they should start, so they go this way. And then the x ones turn around and do the exact same pattern, go in the other direction. Where this square root over 2 comes from Pythagorean theorem, and I'm going to show you that a little bit on the next slide, but that's the pattern for how we get these basics. So let me show you a few where some of this is coming from. All right, what I actually want to show you is this unit circle as a whole first before we talk about where it comes from and the functions. So notice this is the entire circle. And the pattern is very similar across the circle. I usually just memorize the first quadrant and then match things around. And so I'll show you what I mean. In this first quadrant right here, so this is the first quadrant, everything in this quadrant is positive, positive. When we move to the second quadrant, everything becomes negative, positive. And you'll notice that when you look at these coordinate values, if I zoom in, like you can see everything, the x is negative and the y is positive. All right, this same kind of idea moves around the circle. So down here we have negative, negative in the third quadrant. And in the fourth quadrant we have positive, negative. So what I want to show you is how I match those, what I mean by that. So notice that if you match across, it's just all like a game of reflection, right? So if you needed to know this point, for example, it would be the same as this reference point in the first quadrant, except it's negative and then positive, the value. Okay, if you needed to match in the fourth quadrant, let's say you needed to match this one, so I'm going to reflect back to this first quadrant, and it's this same point, right? These values match, except in the fourth quadrant it's positive and then negative. So So now the hardest one to kind of bounce is the third quadrant to figure out where those things match to. So for instance, let's say you needed this coordinate. So on this one, you're going to have to reflect kind of 2 times because it's reflection. It's not a rotation or anything. So I'm going to reflect this way and then this way, right? I'm matching straight across. So it matches with this coordinate, the 1/2 square root of 3 over 2. But the difference is that in the third quadrant, everything is negative, negative. So that point then would be negative 1/2, negative square root of 3 over 2. All right, so now you know how to match and use the circle. All right, so talking about those trig functions, this is just a visual of where that comes from. I keep trying to tell you that it's about triangles, but as you can see here, if we're looking in the triangles, this is the triangle within the unit circle, and it's the same triangle. So notice the radius is 1, right? That still matches. Cosine is this x value, and sine, should probably be changing colors here, sine is the y value right here. I'll recode that so you can see how that matches. All right, so the big thing that you need to write down is that coordinates are cosine and then sine in that order. So cosine is the x value, sine is the y value. Now some of you ask, like, what's this little thing right here? And I'll write that out for you. It's theta. And it is just telling you which angle to look at to answer like the sine or the cosine value. So the only other trig function that you need to know about is tangent, and tangent is a slope function. Those of you that are going to take pre-cal, this is going to come in handy. Tangent has to do with rate of change, and you know rate of change is y over x, right? Rise over run, y over x. So tangent is sine over cosine. So these are the two kind of big formulas that you need to know. And I'm about to show you an example of each one so you can see how to work these out. Okay, so this first one is asking you to find the sine of 5 pi over 6. So sine, if you remember, that's the y value. So on your circle, you're going to look for 5 pi over 6, and you're just answering what the y value is. So the y value at 5 pi over 6 is 1/2. And that's your answer. There's nothing else about that. It's just knowing how to match everything up. Cosine, so cosine is telling me to find the x value, and it's telling me to look for 270 degrees. So on my circle, I find 270. That's this point, and the x value there looks like it's 0, so the answer is 0. It is honestly that simple, as long as you have your circle in front of you, so make sure you've got it. All right, we're going to do 3 quick examples on tangent. So remember, tangent is sine over cosine, or y over x. It's a slope function. So first of all, tangent of 3 pi over 4, so I'm going to find that. So this tells me to do y over x. So that's 1, and this is a bad, this is written poorly. Square root of 2 over 2 is what you should have written down, and negative square root of 2 over 2. So now that looks kind of crazy. That's a fraction inside of a fraction. There's square roots, blah, blah, blah. This is not nearly as difficult as you think it is. These two things completely cancel out with each other, right? So that's the exact same thing on top of itself. So the only thing you're left with is that negative. So the answer here then is just -1. So the tangent there is at -1. Because you're dividing the same thing by itself, it's just negative. All right, tangent of 90. So if I go to my next example, so I found 90 degrees, which is going to give me this point. So that's y over x. So 1 over 0. You can't divide by 0. If you try to type that in your calculator, it's not going to work. So this is actually undefined. That's why I wanted to show you that one. If you get one that is, so if you want to make like a little note, if you get 0 over 1, that equals 0. But 1 over 0 is undefined. All right, and then our last one right here is pi over 3. So if I try to find pi over 3, that's right here. So again, I'm going to do y over x, sine over cosine. So y is square root of 3 over 2 over 1/2. And again, that might look messy, but think about how you could maybe simplify that. Even if you don't know like all the rules, if you try to simplify that at all, hopefully you see, well, they're both divided by 2, so maybe I can just cross those out, which you can. And so then this is just square root of 3 over 1, which is the same thing as just the square root of 3, because anything divided by 1 is itself. So the answer to that one would just be the square root of 3. All right, there is one more quick example I want to show you. So tangent of 11 pi over 6. I've just pulled this off the circle. Again, these denominators are both the same, so we can drop them. So this leaves me, you should remember that from rationals when we did that. So that leaves you with negative 1 over the square root of 3. And hopefully, and some of you may not, and that's fine, but at some point this should register to you that you cannot leave this on the bottom. That means we have to fix it, so we can't leave that square root there. And so when we would try to fix that is we would add another square root there, and I shouldn't have said add, we multiply another square root there so that we can fix the issue. Because now this becomes negative 1 square root of 3 over the square root of 9. And the reason that fixes the issue is because 9 has a square root. So the answer to this is negative square root of 3 over 3. And I know that might look a little more complicated, but this is called rationalizing the denominator. And that's just the best way to write that. Particularly those of you that are going to take pre-cal or calculus, you're going to see that again. So I just wanted to make sure I showed that to you.